Okay, wanted to talk a little bit about combinations. So in the last section we looked at permutations, and we found that permutations were arrangements where order was important. In the case of combinations, they're similar to permutations, so we're looking for order, how many ways of doing something, but it's one where in combinations, order is not important. So don't worry about order in combinations. So here's some examples, like whether you get the 7 first or the 14 first, you're getting a 7 and a 14 under the B, so it doesn't matter which order they get there, you get them. Similarly, if you're looking at a lotto thing, where the order that those numbers come out when they pull the balls or whatever they do to find the winners, the order of these numbers isn't important. It's just that you have those 6 numbers. Or if you have some cards like these ones, the order that you get the ace, 10, and the queen doesn't matter. I guess in a game, if that does matter, then it would be a permutation. But typically, if you get 3 cards dealt to you turn them over and see what they are. It doesn't matter if there's an ace first, then a 10 or a queen, or any other order. You just have those cards. So that would be called a combination. One of my sort of pet things is sort of silly, but typically you call this a combination lock. But by definition, combination is one where it's not important. So if you're trying to find, like to put your combination in this particular lock, the order that you put the numbers in is important. So really, we should call that a permutation lock. Yeah, it's sort of silly, but anyway, combinations, order not important. So here's some examples. Find the 3-letter combinations that can be taken from this set. So I have A, B, C, D, E, and I want to know how many different 3-letter combinations there are. And how would that number compare with how many permutations there are? So if order is important, would you get more or less arrangements? Let's just take a quick look. If you look at A, B, and C, if you did an ABC like that or an ACB like that, these, in terms of permutations, are 2 different things because the order is different. But in terms of combinations, that's just one thing because you have an A, a B, and a C. It doesn't matter what order they come in. So this would be an example of a combination. Or where order doesn't matter, it'd be combination. There'd only be one because you have an A, B, and C. Here's a nice chart from our textbook that sort of illustrates that. So if you have an ABC, that's one combination. In terms of a permutation, that's like 6 different permutations because order is important. So here's a formula that you can use to calculate permutations, or not permutations, combinations of an arrangement. And you can write it a lot of different ways. Like if you have 7, choose 2, you could write it like that. Or you can write it as 7, choose 2. Here's a formula that you can use also to determine that. So it would be 7 factorial over 2 factorial, 7 minus 2 factorial. So you could plug that into your calculator and figure it. Or most calculators now have a button that works with that. Like here on a Texas Instrument one, if you go 7 and then you hit the math button and then you want to go over to the PRB part and then go down to choose right there, so you pick that one, third one, 7, choose 2, and hit go. It'll tell you how many combinations that is. So this particular one comes out to 21. Let's look at some examples of doing that. I guess you could do these on your calculator too if you wanted to. But here's some examples. Lotto, 6 balls from 49. So how many ways could you do that? So on your calculator, you could go 49, choose 6. We're choosing because the order that the balls come out in doesn't matter. So it'd be 49, choose 6. Let's just see what that comes out to. Come on. So 49, math, PRB, choose 6. Okay. Ooh, that's a big number. 13,983. 13,983 and change. So there's 13,000 different combinations of numbers of 6 numbers that I could get from a total pool of 49 numbers or balls, whatever. So in this particular question, if the lotto is worth 50,000, if you just had to pay $1 a ticket, you could theoretically buy that many 13, say 14 million tickets and have covered every possible answer or every possible outcome. And so if it was worth 50 million and you paid 14 million to get for tickets, then yeah, you'd be out ahead. But if somebody else bought the same ticket, that might cut into your winnings. Another example, 30 students separated in groups of 3. How many ways could you do that? Well, it doesn't matter the order that they come in, so they don't have a specific job. So you just say 30, choose 3. That's how many ways it would be. If you are dealing 2 cards, and each deck is typically has 52 cards in it, so the number of ways you could get 2 cards from 52 would be 52 choose 2, and whatever that answer comes out to. Fairly big one. I'm always impressed with the poker players that they really know the odds or the probability whether they're going to win or not on a hand just by virtue of what they look at. I'm always impressed with that. I'm not a real poker player, but I like watching it just to read their odds. Here's another, just an interesting kind of question that would be similar to what we're looking at, but it also joins in the fundamental counting principle. If you have a committee, you've got 7 women, 8 men. On the committee, you have to have 6 people, and you have to have 3 men and 3 women. So the question is how many ways you can do that. Well, in there, there's 2 separate things that you're doing. First, you're picking the women, and then you're picking the men. So to figure out how many ways you can pick the women, it doesn't matter what order they come in. And so you just say how many women there are. There's 7. And from them, I'm going to choose 3. Because it has to have 3 men, 3 women on the committee. So 7 choose 3. That would be how many ways I could get a woman on the committee. And then for men, there's 8 men, and again, I have to choose 3 of those. So this would tell me how many ways or arrangements, ways I can make a committee out of 3 men from 8. This would tell me how many ways I could do it for women. And if I want to merge those 2, so if I want to figure out how many ways I could do both of those, then that's the fundamental counting principle where you multiply this by that. Okay, hopefully that gives you a little bit of practice with using combinations. Notice that it's different than permutation. Permutations, order is important. Combinations, order is not important.